Hello and welcome friends. In this particular module, we wish to discuss about use of plane table for land surveying. We'll get acquainted with salient features of the plane table, principle of plane tabling, the equipment accessories of plane table, and how we can set up the plane table and how we can carry out the temporary adjustments as well as adjustments, advantages and disadvantages. As you learn the content, you'll be able to state principle of plane tabling and also uses of the various accessories that are used for plane tabling. In addition, you'll be able to demonstrate setting up, carrying out the temporary adjustment and use of plane tabling for land surveying. Let's try to get the overall view of plane table. Let's try to understand this particular first setup. Here we are choosing two dominant stations like station A and station B, which are marked on the ground by following usual practices. We reduce this particular dimension as AB on the plane table that is being used for surveying purpose. So, overall setup of the plane table will be like this: tripod and the surface of the plane table and the surveyor who is using that particular plane table with the associated tape. Now, in this particular plane tabling process, we wish to plot the features like, say, various buildings marked as B1, B2, B3, B4, etc. The position of the nala that is adjacent to the site, some particular feature and such things. So here, with respect to that particular station, A and B will be producing various rays so that that particular rays will be scaled down, and actually whatever the features that you see on the site will be plotted on the paper that is provided on that particular plane table. So overall, here the picture that you see is like this. This is the site under consideration. This is some baseline chosen in order to plot that particular features. Accordingly, we produce certain rates, we scale them down and we plot that particular features. So, plane table surveying is a conventional method of land surveying. It is less accurate than modern surveying techniques, but the process wise it's very easy and still it has got many applications as far as minor surveying works are concerned. More about this we'll discuss in coming presentations. So, as we got introduced with the concept, it is graphical method in which field work and plotting are done simultaneously. It is one of the most rapid methods. It is easier. It is also cheaper. There are no spares or costly spares are involved. That's why it is cheaper. The topographic features are to be mapped are in full view. Hence, the omission of that particular features is not possible. Even one can make use of this particular technique in order to fill in the details. Say for example, if you are working with some Theodula traverse, which is quite bigger one, and now we wish to plot the details of that particular say portion of the traverse surveyed, which is called as filling in the details. So here this particular technique will be very useful for filling in the details for major traverses. It works on the principle of parallelism. That is, all the rays that are drawn through the various objects and the survey stations on the paper are parallel to lines from the survey station to the object on the ground. Here, the way you see, O is instrument station, capital A, capital B, capital C are ground stations. Their positions are reduced on the paper as small a, small b, small c. Now, here the way you see, ray OA, which is yellow, and the ray OA, which is red, that are partially overlapping each other, but essentially they are parallel to each other. Same is with capital B, capital C, and accordingly here the principle can be easily understood. In order to observe this particular principle, the position of the plane table at each station must be identical. That is, at each survey station, the table must be parallel to the position that it occupied in earlier station. Usually, this particular requirement is satisfied by making use of magnetic north or suitable meridian that is chosen as one starts the work. Let's try to understand about the various accessories that are involved for this particular plane tabling. Essential requirement is of plane table. It is essentially the drawing board which is made from well seasoned wood with its upper surface plain and smooth. It is rectangular in shape and normally its size is 60 cm by 75 cm. This particular table is mounted on a tripod and it can be revolved about its vertical axis and it can be clamped as and when required in the direction that surveyor is interested in. Usually, this particular tripod is open frame type. It is combined rigidity with lightness. Sometimes it could also be folding type for ease of the transportation. It is also equipped with some of the accessories that we will be discussing subsequently, but the essential one is eyelid, which in turn can be simple eyelid or telescopic eyelid. So here this is what you see. There are variety of the tripods. Essentially it could be open A frame type. Here the head of this particular tripod is provided with certain fly nut assembly which facilitated clamping and rotation of this particular plane table about the vertical axis. So this is about the plain eyelid or simple eyelid. It is used for ordinary works. Usually it is wooden or the brass ruler 50 to 60 centimeter length. It is also called as side rule. The way you see here, it is having certain trapezoidal section which is provided with this particular beveled edges. It is comparatively heavy so that it would be kept and would be remaining stationary at the requisite position. It is provided with the eye vane at one end and it is provided with the object vane at other end. Eye vane is normally this particular rectangular window. So here the observer can look through that particular rectangular window, and on the opposite side this particular object vane is provided with the vertical crosshair so that this particular line of sight would be joining the vertical window at the observer end and other at object end. As such, the line of sight is joining the eye vane and object vane and helps to bisect the object under consideration. This particular base of this eyelid is provided with this particular beveled edge, which is called as fiducial edge. This fiducial edge is helpful to draw the rays towards the object under consideration. Sometimes it is provided with graduations so that it can be used for the plotting of the dimensions that are actually measured on site to reduce it to the requisite scale. The other type of the elided is telescopic elided. The way you see, the lower portion is very similar to that particular plane elided, but it is not equipped with that particular eye vane and object vane. Here, it is provided with that particular some kind of level tube or pond level in order to facilitate the horizontality of the base. In addition, the way you see, it is provided with some spindle, it is provided with a graduated arc, also it is provided with this particular telescope, intern, eyepiece, object glass. As such, as and when required, by making use of that particular clamping screw, we can release the position of this particular telescope, and accordingly it can be moved in the vertical plane to sight the object placed above the line of sight or below the line of sight. So here this particular telescopic elided will serve many purposes. It may act as even level sometimes in order to record the levels, in order to sight the objects, in order to determine the elevations of the object lying above the line of sight or below the line of sight. It can also facilitate the contouring operation. So it has got many applications as far as working of the plane tabling is concerned. We have discussed the use of this particular telescopic elided along with this particular plane tabling for contouring in another presentation that is available over the channel. Here, what you see is nothing but the Trupp compass. It is used in order to present the magnetic meridian of the paper. It can also be used in order to have the plane table positions kept identical to each other by making use of magnetic meridian. More about this in coming slides. Also, in order to facilitate leveling operation, it is equipped with spirit level. As we discussed in the previous slides, in the plane tabling, the fieldwork as well as the plotting is done simultaneously. Hence, one of the accessories is drawing paper along with the drawing accessories. One of the important operations in the plane tabling is to transfer the ground station on the paper or vice versa. That is to transfer the position available on the paper on the ground. So, in order to facilitate this, we make use of this U fork provided with plumb bob. So, setting up the plane table and carrying out the temporary adjustments need specific attention as far as plane tabling is concerned. So, the first thing is fixing the plane table on the tripod. This particular plane table needs to be properly fixed on the tripod stand. White drawing sheet is then placed on this particular flat table and properly fixed with certain clips or even the press pins or thumb screws. During the whole process of this particular plane table surveying, one must take care that the position of the paper won't be misplaced. Now the next thing is leveling the plane table. So the plane table is properly leveled by using spirit level. The plane table should be parallel to ground surface initially. Then the on the top of this particular table, we keep the spirit level tube parallel to any face. We bring the bubble at the center of its run by tilting this particular top of the table by making use of tripod, or otherwise if some equipment are provided with ball and socket arrangement, it can also help in order to bring this particular surface into horizontality. Then we will alter the position of that particular level tube, that is, we will make it perpendicular to our earlier position, and again we will bring the bubble at the center of its run. As such, the leveling of the table is facilitated. Now the next thing is, say this is the station on which we are working. So we have to choose this particular station on the table. So the way we discussed earlier, we can make use of plumbing fork so that that plumb bob will be moving exactly over this particular peg, and accordingly the V position of that particular U4 can be used in order to mark that particular station. Sometimes the station could have been marked earlier on the paper. So here that particular V mark of that particular plumbing fork will be coinciding with the marked station. Now that particular plumb bob attached to the lower end of that particular U4 must be flowing over that particular peg. So this particular thing is done through this particular centering the table. As we do so, the next thing that is required is marking the north line. So after setting the table, leveling the table, centering the table, now in the upper right corner, by making use of rough compass, we mark a line representing the magnetic north direction. As we proceed further, we need orientation of the plane table. So it is the process of setting the plane table into some fixed direction so that line representing that particular certain direction on the plan is parallel to direction on the ground. This is the position of the plane table. This is first position of leveling tube. As we place this, let's take reference to the position of the bubble and have the bubble brought at the center in order to ensure horizontality along the longitudinal axis of level tube. Then we'll keep this particular level tube perpendicular to the first position. Again, bring the bubble at the center by making use of legs, or by tilting the top of the table, or by making use of ball and socket arrangement so that the horizontality is ensured. Next thing is centering operation. So this particular line should be passing through the peg on the ground as well as the position that is marked on the paper. And finally, we'll mark the magnetic north direction in the upper right corner. There are certain advantages of the plane table surveying. In fact, as we measure in situ conditions and as we plot the features on site condition itself, it is unique technique of land surveying. The way we discussed initially, all the field that we are working on is in view, hence there are very small chances of omitting the land features to be surveyed. The way you see here, this is certain station A, this is certain station B. With respect to station A as well as B, we can mark certain stations alternatively like C, D, E, etc. So accordingly, though we are simply interested in plotting this particular station B from A, we can produce the ray towards say C. If possible, we can measure that particular distance AC, we can reduce it to some scale and we can have that particular AC referred. As we go to station B, we have to carry out that orientation operation, and as we produce the ray from B towards C, it should pass through the earlier marked position. As such, the errors and mistakes can be checked while preparing the drawing on the site itself. Even it is quite possible that irregular features can be plotted accurately as the extent of the land is in direct view. Also, we discussed about the making use of this particular technique for filling in the details. Also, the technique is very rapid. Do not take the exact meaning, but here no great skill is required as far as the plotting of these particular surveying features. It is less costlier. Even the way we discussed about the prismatic compass or compass in general, it may get affected because of local magnetic influence. Such is not the case as far as plane table is concerned. In another surveying techniques, field recordings is essential because that particular recordings we are using for the plotting purpose. Here, as we are plotting the features on site itself, there may not be need of the field notes, but there could be some features which are not plotted. Say for example, time of surveying, the weather condition, visibility, and some say the position of the station on the ground, vegetation cover, and some such information which may aid the interpretation of this particular surveying operation. In addition, we must think about the disadvantages of the plane tabling. Obviously, we are making use of paper in order to prepare the drawing on site circumstances. As such, it is not suitable in wet climate. Even if it is a densely wooded country, we may not be able to cite the features, hence we won't be able to plot the features. The absence of the measurements are inconvenient if the survey is to be replotted to some different scale in office space. As we discussed here, we need truck compass, we need that plumbing fork, we need that particular plumb bob, we need truck compass, pencil, and so many such accessories. So it is awkward to carry all these particular accessories. The setup is usually heavy. One more thing is, we do not expect it for very accurate results. Having the setup very bulky, it is inconvenient to transport. Even the way we discussed here, as it is awkward and as we need lot many accessories, there are quite a chances of losing that particular say accessories on a particular site. This sketch is depicting most of the things. The way you see, the surveyor is standing on very awkward position. Water body is there. One assistant is using umbrella. Still, if the surveyor has that kind of the skill, as the surveyor has got that kind of the skill, he can make use of this particular technique even in adverse situation. Orientation is one of the important process. In fact, it can be treated as heart of plane table traversing. It is the process of setting the plane table into some fixed direction so that the line representing a certain direction on the plan is parallel to that direction on the ground. It can be facilitated by making use of drug compass or another technique of backsighting. So the way you see here, work is started from station A. The way we discussed earlier, the last step was to orient the table. That is, after marking the north direction in the upper right corner. Now, here all that particular relationship of the line will be established with that. So, here if this is the magnetic north direction that is plotted at station A, it has to be parallel to the magnetic north direction that is prevailing for that particular site. Now, as we move further to station B, here again, that particular magnetic north direction which is prevailing on the paper and that is existing on the ground should be made parallel to each other. That is, here the setup at B is very identical to setup that was at A. As such, the way you see all the way while moving from A to B, B to C, C to D, D to E, and again coming back to A, that is after while following this particular traverse A, B, C, D, E, A, all the setup are identical to each other. Let's try to understand how we can make use of drug compass. Say for example, this is station A, that is instrument station 1, and this is station B, that is instrument station 2. Initially, we have occupied station A. So, we have plotted the magnetic north direction by making use of drug compass. We have drawn the ray towards station B. By making use of some scale, we have reduced it as small b as far as positioning on station A is concerned. Now, with respect to A, what are the features that we wish to plot? That can be plotted by making use of suitable plane tabling methods. Now, as we move to station B, here the plotted position small a, small b should be parallel to capital A, capital B, which is nothing but making the second position of the plane table identical as it was on its earlier station. In technical terms, will be orienting the plane table at station B in the similar manner the way it was at station A. So, let's make use of drug compass. Let's have the drug compass placed adjacent to the plotted magnetic north direction. Obviously, here the needle won't be giving the 0, 0 position, but it would be touching the side edge of that particular drug compass. Now, turn this particular table about its vertical axis so that the needle will be flowing freely and the needle will show 0, 0 mark, that is, it will be parallel to the one which is plotted earlier. As such, all the edges of this particular table will be parallel to the respective edges of the plane table positioning as it was at station A. So, here as this is achieved, we can clamp the position of the table. In addition, just try to understand, say with respect to A, if we have plotted some more station C, and now As we occupy the station B, as we carry out the orientation operation, as we look through this particular B towards the station B that is existing on the side, here station C that is existing on the side, it should be passing through the station marked with respect to station A. As such, the orientation done by trip compass can be assessed by making use of suitable supplementary techniques that will solely depend on the surveyor who is working on the site. Needless to say, trip compass works with the magnetic needle. If there is certain magnetic influence, naturally, because of such local attractions, we cannot achieve the orientation correctly by making use of trip compass. Hence, we can make use of second method. The way we discussed earlier, this is instrument station setup 1, this is instrument station setup 2. Station A is marked as small a. With respect to that, small b, that is station B, is plotted. Even we have plotted some another station C by using suitable technique. We have now the magnetic north direction. As we have plotted the necessary features from station A, now we can move the table to station B. Let's make use of trip compass and have the table oriented. Have the table oriented by making use of the method that we discussed on earlier slide. Hence, now the plotted AB must be parallel to capital AB that is existing on the ground. But the way we discussed previously, though the equipment is centered with respect to B on capital B that is existing on the ground, because of the magnetic influence, it may not be giving the identical position the way it was on the earlier setup. Hence, what we have to do is keep the fiducial edge of the alided adjacent to BA. Now, look through the eye vein and see, as we look through the object vein, the ray that is nothing but the line of sight passes through station A prevailing on the ground. So for that, if the line of sight is not moving through that particular capital A, which could be peg, which could be ranging rod, rotate the telescope in such a manner that ray BA will be passing through the station A marked on the ground. As such, because of this particular back sighting, AB will be exactly parallel to AB. Magnetic north plotted existing will also be parallel to each other. Further, now the way we discussed previously, through B, now we can sight station C. As we have the plotted position of this particular station C, from B also, the ray must be passing through that particular station C. As it is done, we can say the orientation is correct one. So, thank you friends for your attention. I hope the concepts that we discussed are clear to you. In the next presentation, we'll speak more about the methods of plane table surveying. So whatever leveling operation, centering operation, orientation operation that we discussed in this particular presentation will also be referred back as we discuss these particular methods. So bye till then, I wish you very happy learning. Thank you very much.